In this video, I would like to show you how to construct more compound rules which have more than one premises. Let's say I would like to introduce another rule about somebody likes someone. Therefore, now on the left-hand side of this rule, I'm going to use two variables as parameters. And let's say I would like to specify that this rule is only about persons. Therefore, I'm saying that X must be a person. Of course, person is going to be a brand new predicate, and Y is supposed to be a person as well. And let's say I'm going to introduce a third predicate, a third premise, which says that Y must be nice as well. So now you can see a rule with three premises. If all those premises are true at the same time, then the conclusion must hold as well. Okay, since I have introduced two new predicates, let me just introduce new facts about them. So let me say that Gabe is a person and Judith is a person as well. And you know what? Let me introduce a third person, Joe. I have three persons in my knowledge base, so let me just choose Judith to be nice. Okay, so now let's ask questions about persons, who likes whom. So let me ask if Gabe likes Judith. What do you think? What the answer should be? So let's analyze what is going to happen. This query will be matched against this left-hand side here. So X is going to be substituted with Gabe, Y with Judith. Both of them are supposed to be persons, and actually this is the case because of those two facts. Also, Judith should be nice, and yeah, she is nice because I fixed this as a fact. So because all of those, the answer should be true in this case, and it is. Let me ask another question. I would like to check if Gabe likes Joe. The difference between this query and the previous one is that there is no fact about Joe being nice, so therefore the answer is false. So Gabe does not like Joe. At least this fact does not follow from the knowledge base. I would like to show you that you can use variables not only in facts, not only in rules, but also in queries. And this is really cool. You can ask very generic questions. For instance, you can ask whom Joe likes. You see, I'm using a variable here. So I will get every possible substitutions into this variable. Okay, so first answer is X substituted with Y. Why? Because of the first fact, of course. Let's click on the next button. Now I get another solution, beer, I guess because of the second fact here. Then let me click on the next button, and I get some other answer, again, wine, I guess because of this rule and because wine is delicious. And you will get several other answers. Here you can use those other buttons. You can ask for the next 10 or 100 or 1000 answers. Let me just click on 10, and here you get all the possible answers with Judith at the very end. So this is really cool. If you use variables in queries, then the Prolog interpreter gives all the possible substitutions into those variables. So basically, you get the possible solutions. Of course, you can use variables anywhere. You can use them as a first parameter, as the first parameter here. So now I ask the question, who likes Judith? Okay, Gabe definitely likes Judith, and other persons do as well, because of course here you can substitute all the three persons into the variable x, and this is why, for instance, you get the second solution. Judith likes herself because she is a nice person. And finally, I would like to show you that you can even generalize your query even more. You can use variables everywhere and ask this very, very generic question: who likes whom, based on my knowledge base. Now I'm going to get pairs of possible substitutions into those two variables. For instance, Gabe likes wine, and if you click on the buttons, you get all the possible substitutions. This is the first pair, this is the second one, and so on. So these are all the possible substitutions into our variables. For instance, let me just check out the very last one. Joe likes Judith. This is also a possible solution here.